Hello friends, welcome to Susan and John MathTube. In this video, we are going to learn about linear differential equation. Now, linear differential equation means it is in the form dy by dx plus p into y is equal to q. And you have to understand that p and q are functions in x. It can be sin x, it can be log x, it can be x square. And the best way to understand this, p and q are functions in this variable. Can you see? We have dy by dx, right? So we have x over here. So p and q are functions in the same letter. For example, when you are doing applications in civil engineering or in electrical engineering, you might end up with di by dt in some application. And here p and q will be functions in t. Or in some other problem, actually we will be learning something called Bernoulli's equation in the next video, and you might end up with dt by dz. In this case, p and q will be functions in z. I'm just going to give you the procedure. You're not learning the method in with full logic, but I'll give it as a procedure. So what you do is, once you recognize an equation is linear, once you recognize your equation or the equation which you're going to solve or trying to solve in an application is linear, the first thing to do is you have to find something called the integrating factor. So what will you find first? The integrating factor, which is given by e to the power integral p dx, provided we have dy by dx. Okay, once you find integrating factor, the actual procedure is, if you look at most of the very good quality books, what they do is they won't make you by heart a formula or anything. What they do is they will multiply throughout by that factor. Actually, integrating factor means a quantity which will help us in integration, or a quantity when you multiply throughout the equation will make it easy to integrate. Okay, anyway, here we have made a ready-made solution and you have to by heart the solution. And the ready-made solution is y into integrating factor is equal to integral q into integrating factor dx plus c. Okay, now let's go for an example. By the way, I hope you remember the functions e power x and log x. Strictly speaking, log x to the base c, or ln x. These are inverse functions, just like our squaring function and square root function, just like our trigonometric function sin x and sin inverse x. This e power x and log x are inverse functions. So whenever they meet each other, in the sense whenever it comes as a chain function, for example, if you see root under x squared, you know the answer will be x. Or if you see root under x the whole square, the answer will be x. Similarly, sin inverse sin 30 degree, the answer will be 30 degree. So similarly, you should remember e to the power log x. Can you see? These two functions come as a chain function, and the answer will be the argument, that is x. And same thing with log e to the power x. The answer will be x. And I hope you are good with the properties of logarithm. Log a to the power b. What is log a to the power b? Yeah, b into log a. Okay, let's try one question. So please write the first question. Solve the differential equation dy by dx plus y into tan x is equal to sec x. Now look at this. This is obvious. This equation is in the standard form, that is dy by dx plus p into y is equal to q. And like I told you before, you can see that we have dy by dx, and that implies our p and q are functions in which letter? X. Okay, so what's the first thing to do? Okay, comparing with the standard equation, p is equal to tan x, q is equal to sec x, so that our integrating factor will be e to the power integral p dx, and that will be e to the power integral tan x dx. And I hope you are good with these formulae. What is integration of tan x? Log. Strictly speaking, you should use natural logarithm, or you should write log to the base c. But in most of your books, I saw they're casually writing log in the assumption. In calculus, we use the base e. Okay, so integral tan x is log sec x. So we end up with e to the power log. Just now I told you, exponential function and logarithmic function, natural logarithmic function, are inverse of each other. So you are going to end up with sec x. Now, what is the solution? I told you had to by heart the ready-made solution. The solution is y into integrating factor is equal to integral q into integrating factor dx plus c. Now that's it. You have a ready-made solution. So all you have to do is you have to plug this if into the solution. So we get y into sec x is equal to integral q. What is q? Sec x. And what is if? Sec x. So sec x into sec x makes it sec square x dx plus c. So one question. What is the derivative of tan x? Listen carefully. What is the differentiation of tan x? It is sec square x. So what will be integration of sec square x? Of course, tan x. So at the end we get y into sec x is equal to tan x plus c. That's it. Now look at this. Some authors, to be honest, this is the solution, and you will get marks for sure. They have to give you mark for this. But some authors are like very specific. Do you still remember what I mean by solution of a differential equation? Solution of a differential equation means the value or values of y. By the way, using the word value might be sounding a little bit wrong. It is actually the function which will balance this differential equation. So some people are like a little bit more specific. They will feel as if they want the value of y. And such people may ask you to divide throughout by the quantity along with y. I don't prefer that. So in case you want to simplify it, but don't make a mess out of it. You can simplify c by sec x. And remember, this is not constant. For example, in the variable separable type I told you, when you get c by 2, you are allowed to replace it with c itself. But look at this. This is not c by 2. This is not constant by constant. This is constant by variable. So you have to leave it as such. Okay, now let's try one more problem. So please write the question. Solve the differential equation dy by dx plus y into cot x is equal to 2 into cos x. Okay, obviously linear. So you can write comparing with the standard form. Come on, what's the standard form here? Dy by dx plus p into y is equal to q. And blah blah blah, comparing with the standard equation, p is equal to cot x and q is equal to how much? 2 cos x. You can write all those stuff in your exam. Now, what is the integrating factor? What's the formula? E to the power integral p, is it dx? Yeah, because I can see dy by dx, and that gives me e to the power integral cot x dx. By the way, what is integration of cot x? One very important thing. In examination, I've seen so many students making a mess with the formula. So please put it as a article on your high priority, that all the formulae are in very good condition. So we get e to the power integral cot x, and that will be log, and as I always say, to be honest, log to the base c or natural logarithm of sin x. Now look at this. We have a chain function, exponential and logarithmic. So they are going to get converted into identity function. So you end up with sin x. Now what is the final solution? Y into if. In examination, it is better that you write the formula so that you don't make any mistakes. So y into sin x is equal to integral q into if, that will be sin x again, dx plus c. Now substitute, and some basic integration is left. What is q? 2 cos x. Now you need a little bit of trigonometry. Come on, think about it. What is 2 sin theta cos theta? Anyone? Yeah, that will be sin 2 theta, right? So we end up with y into sin x equal to integral. What is 2 sin theta cos theta? Yeah, sin 2 theta. That's it. Now you can apply the formula y into sin x is equal to, what is integration of sin? Minus cos 2x, the whole divided by 2. That's it. And if you are like what you call very, very specific, you find the value of y, you cross multiply by 2, etc, etc, etc. That's your wish. Now let's do a little bit more tough problem. But before we start, I hope you remember integration by parts. Integral u into v. Do you remember? Yeah, it goes like u integration of v minus, inside a very big integral, derivative of u into integration of v dx. I have a like what you call small trick for this. So you can try this trick. What you have to do is you write u. By the way, the order in which the function should be is I late. I hope you remember this. Inverse function, logarithmic, algebraic, trigonometric, and exponential. So the trick is you write u and the derivative of u and integration of v 2 times. Multiply this, simplify it in your brain. Multiply this, simplify it in your brain, and substitute so that there won't be a mess with integral inside integral, because if you write too much integrals in the answer paper, it will be a mess, and the more mess you create, you might make careless mistake. And in mathematics there is a big problem. If your final answer is not correct, you may not even get a single mark. Okay, so let's go for the next question. So please write, solve the differential equation sin x into dy by dx plus y into cos x is equal to x into sin x. Okay, now this equation looks like what you call linear, but it is not linear, because can you see, in the standard form I specified, it must be in the form dy by dx plus something into y is equal to something else. So basically I want dy by dx to have a coefficient 1. Is the coefficient 1 here? No. But it's not a big deal. You divide throughout by sin x so that we get the coefficient of dy by dx as 1. So let's divide. So what's sin x divided by sin x? That will be 1. So you get dy by dx plus y into, what is cos x by sin x? Cot x. And what about x sin x by sin x? You get x. Now the usual dialogue, comparing with the standard equation, we get, okay, tell me, what is the value of p? P is equal to cot x and q is equal to x. So what's the first thing to do? Come on, you can pause the video and try it yourself. So what is the integrating factor? E to the power integral p dx. That will be cot x into dx. What is integration cot x? I think we did it a minute back. Yeah, that will be e to the power log sin x. And as usual, we end up with sin x. Now, the solution is y into integrating factor. I'm a little bit lazy here, but in examination, you will be given only one question. So, make sure your presentation is like proper. Yeah. So, y into sin x is equal to integral q. Where is q? X into sin x dx plus c. So the solution is ready, but we have to do a little bit of integration. Are you able to see our product? I'll color it for you. Are you able to see our product? Yellow and green. Okay. So I'll tell you the shortcut. Anyway, first of all, you have to understand that it matches the requirement ILATE. So x is an algebraic function. So yellow and sin x is a trigonometric function. See, the order is proper. So we are allowed to use integration by parts. Okay, now I'll show you one shortcut. It's not a shortcut, it's a method so that we can avoid that unnecessary integral again and again. So all I wanted to do is write the first function and write the derivative of the first function and tell me the integration of the green function. What is integration of sin x? Minus cos x. Write it 2 times, not once. One below this and one below this. Okay, that's it. Multiply this, simplify this, and tell me what will be the answer. It will be minus x into cos x. Now you have to write minus integral. So look at this, first function, integration of second, we have multiplied it. Now minus integral, multiply this. So what will you get? Minus will be plus. Now that's it. So y into sin x is equal to, by the way, you can use any method you learned before. This is just a memory aid, that's all. And what is integration of cos x? That's it. Now let's go for one more question. The next question is a little bit more important. So please write. Solve the differential equation x log x into dy by dx plus y is equal to 2 into log x. Okay, question number 1. Is this equation in the standard form? No. So how can you make it in the standard form? Very simple. Divide throughout by x into log x. So we end up with dy by dx plus 1 by x into log x. Did you understand? I am dividing throughout by x into log x. And here log x and log x will get cancelled, 2 by x. Now this is in the standard form. So we can write, comparing with the standard equation, dy by dx plus p into y equal to q. So comparing with the standard equation, dy by dx plus p into y equal to q, we have our p and q. Now what's the next thing to do? Integrating factor. What is integrating factor? E to the power integral p dx. That will be 1 by x log x dx. By the way, I hope you don't mind when I write 1 by a into b as 1 by a into 1 by b. Or if I want, I'll write this as 1 by b into 1 by a. Okay, now I'll show you why I told that. Can you see 1 by a into b? I'm going to write it as 1 by log x into 1 by x dx. If you ask me why, the answer is very simple. I can see the derivative of log x as a product. Can you see? So what I'm going to do is I'm going to use method of substitution. When will you use method of substitution? Very simple, when you see function and derivative as a product inside an integral. So I'm going to put log x is equal to any letter that you like. I prefer t. I'm used to that. So what is the derivative of log x? 1 by x. What is the differential of log x? 1 by x dx is equal to dt. So let's substitute. So e to the power integral 1 by t, and the remaining part is dt. What is integration of 1 by t? Log t. Oh, that's good. Can you see? E power log. So their inverse is t, and that will be equal to log x, because the value of t is log x. So we found the integrating factor, and what's the integrating factor? Log x. The solution. What's the solution? Y into integrating factor is equal to integral q. What was that q? Let's go back. 2 by x. So 2 by x into log x dx plus c. Now I hope you don't mind if I throw this 2 outside. It's a constant, it goes outside the integral. And then I'm going to write log x into 1 by x dx. This time I'm sure you understood what I did. Can you see? I can see a function and its derivative in product inside an integral. So I'm going to put log x is equal to w. Because I already used t, I'm not allowed to use t again. There's no problem with that, but still it will cause confusion. So 1 by x dx is equal to dw. So we are almost near the answer. That will be 2 into integral. What is log x? W. And what is 1 by x dw plus c. And that gives me y into log x is equal to 2 into, what is the integration of w to the power 1? W square by 2 plus c. That's it. So we get y into log x, and w is actually log x, so we get log x the whole squared plus c. And if you want, you can find the value of y. Now one last question. Even though it's the last question, it's a very important question. You can look at your past paper question. I have that bunch here, and they have asked a lot of times, a lot of times. So let's go for the question. Please write. Solve the differential equation 1 plus y square. Please mark it, very important. 1 plus y square into dx is equal to tan inverse y minus x dy. Look at this. Even though for some students it might look like, of course it's not homogeneous, but some students always tell me it looks as if it is variable separable. It cannot be variable separable, because can you see x and y are connected by negative, and outside there is a dy. So it will be very difficult for you to separate it in such a way that x will be along with dx and y will be along with dy. Okay, so the only option now you have is, it is not homogeneous because there is, like what you call, it's not even a polynomial here. And it is not reducible to homogeneous. It is not variable separable. Just now I told you. So basically this is linear. Now, do you remember in algebra you might have learned that a minus b divided by c can be split into two fractions. A divided by c minus b divided by c. Okay, so what I'm going to do is, I'm going to write dx equal to tan inverse y minus x the whole divided by 1 plus y square dy. Now I think you can see that a and b. So tan inverse y divided by 1 plus y square minus x divided by 1 plus y square dy. Now I'm going to write this as, I'm just going to take this dy to the left. So dx by dy is equal to tan inverse y by 1 plus y square minus x by 1 plus y square. So we end up with dx by dy plus x by 1 plus y square is equal to tan inverse y by 1 plus y square. Now this is very interesting. This is very interesting. So here you can see that it looks like linear, but we already did 4 questions, and even in your plus 2 you might have learned so many questions in linear. But here we do not have dy by dx. It is dx by dy. So the standard form will be different now. The standard form will be dx by dy plus p into x is equal to q, where p and q are functions of y. So what is p and what is q? Come on, think about it for a minute. Of course, p will be the quantity which is along with x, that is 1 by 1 plus y square. And what is q? Q will be tan inverse y by 1 plus y square. Okay, now as usual, so the integrating factor. What is the formula for integrating factor? E to the power integral p, not dx, here this one, dy. So that will be e to the power integral, what is p? 1 by 1 plus y square dy. That will be e to the power tan inverse y. Please brush your integration formulae if you are not that good with the formulae. Now let's go for the solution. Now wait a minute, the solution will be different. The original solution was y into integrating factor, but here can you see, instead of y we have x. So what's the solution? X into integrating factor is equal to integral q into integrating factor dy plus c. That is x into e to the power tan inverse y is equal to integral q. What is that? Q. Tan inverse y divided by 1 plus y square into e to the power tan inverse y dy plus c. Now this integration looks a little bit complicated, but it is not. So x into e to the power tan inverse y is equal to, look at this, I'm going to rearrange it as usual. I'm going to write tan inverse y into e to the power tan inverse y into 1 by 1 plus y square dy. Now can you guess what should be the next step? I can see a function and the derivative. Can you see? I'll color it for you. If you can guess, that something rhymes. Can you see a function and its derivative? Yeah, I'm going to do that. So I'm going to put tan inverse y is equal to some letter. You can put any letter that you know. I'm going to use u. So 1 by 1 plus y square dy equal to du. So the solution goes like e to the power tan inverse y multiplied by x is equal to integral, what should I write? Yeah, u and e power u and du. Integration by part, 100% integration by parts. Can you see I, L, A, T, E? Let's see. U is an algebraic function and e power u is an exponential function, obviously exponential. The order is correct. So shall we apply the trick? So write the first function, write the derivative of the first function, and now tell me integration of the green function 2 times. What is integration of e to the power u? E to the power u. How many times? 2 times. Now very simple. multiply these two. So x e power tan inverse y. Okay, so that will be u e power u minus integral. Now multiply these two. That is e power u d. See, my idea is very simple. I don't want you to write integral again inside another integral. So this will save a little bit of like what you call 2 or 3 steps and confusion. Tan inverse y equal to u e power u minus integration of e power u is e power u plus c, and then replace the value of u. That's it. So I'll be back soon with another video. In the next video we'll be doing Bernoulli's equation. So till then, my friends, bye.